Warm greetings and wishes to everyone. Today I am going to take a video lecture on the design of RCC structures. The case of the working stress method, we are going to see about the critical neutral axis and actual neutral axis depth. The case of balanced section, under reinforced section and over reinforced section. So if we are taking a beam which is of rectangular cross section which is of width B and depth D, and it have a reinforcement in the tension region, that is below the neutral axis. So you are providing the reinforcement at an effective depth from the top fiber of the beam, and also if you add the effective depth plus the effective cover, you will get the total depth of the beam. And in the case of balanced section, under reinforced section, over reinforced section of RCC beam, we have to locate the neutral axis based on the located neutral axis, that is the critical neutral axis, nothing but for a balanced section, and the actual neutral axis depth, which will be vary from under reinforced section, over reinforced section and a balanced section. So in the case of balanced section, the critical failure will take place simultaneously in the case of concrete as well as the case of tension reinforcement, because the yield criteria will have attained in both cases simultaneously. So therefore, the case of balanced section, the critical neutral axis depth is coincide with the actual neutral axis. So I call the critical neutral axis as XU max, and the actual neutral axis depth I call it as X suffix U. So if you take the beam reinforcement and the actual and critical neutral axis depth for the balanced section, under reinforced section and over reinforced section as shown in the diagram. So in the case of balanced section, right, you can see this is a first one is a balanced section. Here the critical neutral axis is coincide with the XU max, actual neutral axis. That's why both will coincide at the same axis. So actual neutral axis and critical neutral axis. So in the case of balanced section, the critical failure will take place simultaneously in the case of steel as well as in the case of concrete. It's the compression portion. This is the tension portion for the steel. Then if you take the under reinforced section, you can see that the critical neutral axis depth, so this is coincide with the critical neutral axis, but actual neutral axis, what will happen? So because of the reinforcement is less compared to the balanced section, the actual neutral axis depth will shift to the concrete section. That means, so XU here is less than the XU max. XU is the actual neutral axis depth, XU max is the critical neutral axis depth. This is the critical neutral axis depth. So here the failure will occur in the case of the tension region because of the reinforcement reaches its yield criterion and the yield strain fastly than the compression. So the failure will take place in the case of steel. So it is the mode of failure is slow one, because the steel is having the ductility and it will give enough warning. You can rectify the things in the case of the under reinforced section, where XU is less than XU maximum. XU maximum is the critical neutral axis depth and XU is the actual neutral axis. So that is the second diagram. And for the over reinforced section, you can see, so this is the concrete stress strain diagram. You can see here the over reinforced section means what will happen? Sorry, over reinforced section, yes, due to the more percentage of steel compared to the under reinforced section or a balanced section, what will happen? The actual neutral axis will shift below the critical neutral axis depth. This is the critical neutral axis depth, and you can see the actual neutral axis here. So XU is greater than XU maximum. Already you know that XU maximum is the maximum or the actual neutral axis depth is XU, and XU max is the critical neutral axis depth. So here in the case of over reinforced section, so XU is greater than XU maximum. So due to the total happen, the strain will be more in the case of compression, so the failure will occur in the case of concrete. So it is a sudden failure compared to the balanced section and the under reinforced section. The over reinforced section is a sudden failure and is more dangerous. So normally if you are designing the beam, in the case of RCC, you are using the working stress method, you can design as under reinforced section, that is the most economical one, and or you can design as a balanced section, but you should not design as a over reinforced section. So because of the reason that the concrete will not give enough time to rectify the mistake or error, so it is a sudden failure. So this is the comparison between the actual neutral axis depth and critical neutral axis depth. So for the three section, balance section, under reinforced and over reinforced section, we have given the diagram and reason, and due to that only we have to design the beam in the case of working stress method as the under reinforced section or the balance section. You should not design as a over reinforced section because of the failure will occur suddenly in the case of the concrete, because the concrete reaches the yield strain compared to the yield strain of steel. So the failure mode occurs very fast. So you should not design as a over reinforced section. So this is about the comparison between the neutral axis, actual neutral axis and critical neutral axis for three different type of section, that is called as balance section, under reinforced section and over reinforced section. I have drawn all these in neutral axis actual and critical neutral axis depth in three mode of diagrams. Thank you very much for patient listening. We can see some one or two problem in the next video. Thank you very much. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.